All right, begins our lectures on section 3.3. Our objectives are to use a ratio to compare steepness of lines. We are learning the meaning and calculating the slope for non-vertical lines, and we're discussing increasing versus decreasing slope and the relation to the sign of the slope. The slope of a horizontal, and then discussing the slope of horizontal and vertical lines as well, those being 0 and undefined respectively. So the first thing that we want to learn is, what is a slope? A slope is a ratio, and it is the ratio of the vertical change to the horizontal change. Now there's a lot of ways that we can term that slope. First of all, you need to know that the abbreviation that we use is M for slope. If you want to learn why, go and Google it, it's out there. The next thing is that is in the numerator the vertical change, in the denominator the horizontal change. Now this change that we're talking about is the change from one point on a line to the next point on a line. So from one ordered pair to another ordered pair, from one point that satisfies the line to another point that satisfies the line. Another way we can term this change, the vertical change is the rise, like you would rise up and down in an elevator, and the horizontal change is the run, like you'd run on the ground, rise over run. And then we're going to have the slope formula, which is the one that you see here. This says y2 minus y1. Y's are vertical points, right? So the vertical change over the x's, x2 minus x1, horizontal change. Now we'll talk about those little numbers that are written below and to the right in a little bit when we come back to that formula again. And then another way in math and science that we a lot of times will talk about change is to use this symbol that looks like a little triangle. That's actually a Greek letter. It's called delta. And delta in math and science means change. So this says the change in y over the change in x. So we see the definitions here. The rise is the amount of vertical change. That's the change on the y-axis. And the run is the amount of horizontal change, the change on the x-axis. Now, a line that has positive slope is said to climb up when we're viewing it from left to right. It has increasing slope. So this line here, that has increasing slope. As I view it from the left side of the paper to the right side of the paper, it's going up as I go from there. So to get from this point to this point, I would have to climb up the line from left to right. Now a line with negative slope slides down from left to right. So if I look at this line from left to right, this one has negative slope, because to get from this point on the left to this point on the left, or to the right of it, I would have to slide down. As I look left to right, I'm sliding down. It has decreasing slope. And the slopes of these things will have positive numbers, and the slopes of these will have negative numbers. So increasing slopes, we see positive numbers, and decreasing slopes, we'll see negative numbers. Now, when we ask for a slope, we're not actually just talking about the sign. We'll be talking about a numeric value as well, and I don't want you to confuse that. Now there are three methods for us to find the slope of a line, and we're going to talk about two of them in this section. We'll have a formula, that's our first topic, and then we're going to do a visual or a geometric approach, which talks about the rise over the run on an actually on a graph line, and then finally we'll talk about the equation or the model of a line, and that we'll do in a different section. So our first method is what we want to talk about now, and that is using the formula. So this is deemed by your book as the slope formula. So this says that m, the slope, is equal to y2 minus y1 over x2 minus x1, where x1, y1 comes from an ordered pair, and x2, y2 comes from an ordered pair. So that's your second ordered pair. Now these little numbers to the right and below are called subscripts, and they just help us to take care of which ordered pair we're choosing from. And you'll notice right here, y2 and x2 are lined up over one another, and y1 and x1 are lined up over one another. That helps us keep the fact that this set is from an ordered pair and this set is from an ordered pair. Bottom to top ordered pair, bottom to top ordered pair. So we're going to be using this under three sets of circumstances. The first one, which we'll be doing now, and that's when we know 2 points that lie on a line, or 2 points that satisfy it. Then if we have an equation or a model, and then finally if we have a line and we can identify the 2 points on that. So now